All right, hello once again, Jeff Scott of Rankin Technical College. And I've been doing a series of videotape presentations for the AWD, or Application and Web Development 1100 C# programming course at Rankin Technical College. And this is for the online section that's beginning in spring 2024. And again, I've been doing most of these presentations based off the PowerPoint slides that go with our textbook. And our textbook is Muroc C# 8th edition. So far, I'm halfway done with the book. So I've done an introduction to Visual Studio in these 3 chapters, the C# language essentials, and these 8 chapters. So now I'm up to the 5 chapters on object-oriented programming. And I'm going to spend most of my time on 12 and probably 14. All right, we will talk about the other chapters, but not in as much depth and breadth of coverage, just so you're aware of that. All right, I went out online and was looking for a good article on object-oriented programming, and a lot of them are pretty good. This was probably as good as anything else. So I want to take a little bit of time here before we go into chapter 11 and talk about this. All right. Object-oriented programming is a fundamental programming paradigm used by nearly every developer in some point in their career. Well, what does that mean? First of all, a paradigm typically is equated with a paradigm shift, which means it's a shift in a way of doing things. And in many ways, object-oriented programming is a shift in what we've been doing so far. And in many ways, it's not. C# is an object-oriented programming language. So, for instance, in the last program we were just working on here, all right, we created some text boxes, for an example. These are objects of the text box class. We created some labels, which are objects of the label class. We created some buttons, which are objects of the button class, etc. And all I'm trying to say here is, in at least many ways, you have already been using object-oriented programming. All right? So it says, OOP is the most popular programming paradigm used for software development. Probably is. So today we will break down the basics of what makes a program object-oriented so you can start to utilize this paradigm in your algorithms, projects, and interviews. So this is what they're going to discuss in here. What is object-oriented programming, or OOP? The building blocks of OOP. What I want to concentrate, not solely, but a lot on, then, that is these 4 principles of OOP, and then what to learn next. All right. As they mention here, and let's just call it OOP from now on, all right, it relies on the concept of classes and objects. A class is basically a blueprint of what you want objects to look like. All right. Now, I can give you a lot of examples, but let's actually look at something that we've been working with. All right, and that's right here. So if we looked at this, let's just like kind of break this down right now with what we've got. All right. So this is an employee. So let's say that we were going to make a class called employee. So an employee class. All right. Now let's think about what we don't have in here that we might want to put in. Well, we might want an employee number. And that employee number might be a string. And that employee number might be a number. All right. But let's make it a string. So let's start with string. And we'll call it employee number. All right. Now we've already got a string in here for first name. We've got a string in here already for last name. It looks like we've got a bool in here already for has insurance. We've got a checkbox. Well, that's a checkbox. We've got a decimal in here that we have used for hours worked. And again, we've even said that this has to be greater than or equal to 0 and less than less than or equal to 84. And we use constants for that. We have another decimal for hours worked. And we again said that had to be greater than or equal to 0. And it had to be less than or equal to 99.99. And again, we use constants for that. All right. In addition, so those basically are what we would call and we always have one more, I'm sorry, that's in here that's called gross pay. All right. So those right there would probably be known as properties or attributes or something of an employee class. We'll call them attributes. All right. In addition, we had some other stuff in here. All right. And we're going to call those methods. All righty. And we had one method that would figure out, that would actually be returning an int, and it would be total number of employees. We had another one that would be a decimal, and that would be the total payroll. And we had another decimal, and that would be average payroll. Now, why am I taking the time to go through all this stuff with you? What I'm trying to show you is, in many ways, the program that we created sets itself up pretty well to be an object-oriented program. All right? If we have 7 attributes, now I added a new one, so we've got an employee number, a first name, a last name, an insurance, an hours worked, an hourly rate. Oh, and I forgot this birth date. Well, let's put that in there. And while we're at it, so that'd be a date time field. All right, and I think that's always goes in as like this. But we've got a birth date. And one thing we talked about earlier that we really didn't put in here, and that was a hire date. All right. And as you can see, then again, we've got hours worked, hourly rate, and gross pay. Now I am taking this birth date, moving it back up here. I think we even actually did that. I played around with it a little bit. How's that? All right. And then when we put all this information in and click calculate, we got the gross pay. We got the total number of employees. We're increased by 1. We added the gross pay to the total payroll. We divided the total payroll by the total employees to get the average. So we've already got kind of, at least, a good start on being able to create an employee class. And I'm going to do that, not right now. I want to go with what they've got in the book. But I'm just trying to show you here that we kind of already have the good, what's the right word, nucleus or whatever to be using this. So OOP relies on classes and it relies on objects. All right. A class, again, as it says, is a blueprint from which you create objects. The act of creating an object from a class is known as instancing the object, or the act of instantiation. You are instancing or instantiating an object based off of a class. Classes have attributes and they have methods. All right? Attributes are basically, as it says, that's what define an instance of a class. Now, you just saw this with what we did here. All right? But if you can imagine, if we had a person class, so if I literally created a class called person, they might have attributes like height. We might give them first name, last name, but height, eye color, hair color, all right, gender, etc. And there's probably a lot we can think about and think of. All right? In addition, we could give the human or that person class methods. Methods are basically behaviors. All right, so for example, for a person could eat, drink, sleep, etc. So as it says, the class is a blueprint from which you create objects. Classes share attributes. Classes can also contain functions that are known as methods, available to objects of that type. And then they give you some examples in here. You can look at theirs. Again, using this one in here of a car, it's kind of a tried and true type of thing. I'm not going to do that. I'll leave the, this is, and again, this is just one I picked out. There are a lot of really, really, really good resources that you can go to find good articles on what OOP and object orientation is. Let's just get down to here. There, we'll do this, and then I'll blow this up. All right, that's probably big enough. So if you go out to educative.io/blog /object-oriented-programming. Okay. All right. Now, when you start to create objects, you oftentimes create these and put them into what's called a UML or a Unified Modeling Language type of diagram. That's pretty much what we're showing right here. All right. And the way that this is broken up, it's really broken up into thirds. On the top third, you have, for example, the name of your class. Then underneath that, you have your attributes and you have your methods. Now, it doesn't show it exactly here, but typically your attributes will be private, and they'll have a minus sign before them. Your methods usually will be public, and they'll have a plus sign with them. Now, there's more to it than that, and we'll get to this as we go on in here. All right? I was asked once, hey, can you give me a one-sentence definition of object-oriented programming? I said yes. All right? And it's very general or generic in nature, but by and large, you use in object-oriented programming, you modify private data using public methods. All right? Most of your data is private. If it's not private, can it be public? Yes, but it almost never is. But you'll notice when we go on into this a little later, there's going to be another thing in here called protected, which I don't want to get into right now. But typically your data will be private. Typically your data will, your methods rather, will be public. Can you have private methods? Yes. They're usually called helper methods. And we'll get into all that stuff later on. All right, so why do you want to do this? What, as it says here, what are the benefits of using object-oriented programming? The biggest one out of this list that I can think of is number 2. They're reusable. So you can use those across programs. All right? They model complex things. There's something called polymorphism, which stands for many forms, and we'll get into that in a little bit. They're typically, once you get into it and start working with it, you'll find that it's I don't know if it's easier to debug. In many ways, many people have told me it can be more intuitive to debug. And it can securely protect sensitive information through what's called encapsulation. We're going to look at encapsulation. We're going to look at inheritance. We're going to look at polymorphism. And we're going to look at data hiding in a little bit later. Okay? So how do you structure these programs? It says, let's take a real-world problem and conceptually design an object-oriented programming or OOP software program. All right, so this is the one that they're going to use here. Imagine you're running a dog sitting camp with hundreds of pets, and you need to keep track of the name of each pet, the age of each pet, and the number of days each pet will attend the dog sitting camp. And it says, how would you design a simple reusable software to model the dogs? Now, this is just an example. So it says with hundreds of dogs, it would be inefficient to write entries for each dog because there'd be much redundancy. So when you look at this, the only difference between these two, I shouldn't say the only, but what are the differences? Well, Rufus versus Fluffy. The birthdays are different, but everything else in here is the same. And imagine you had hundreds of these dogs. There would be a lot of data duplication. And that's what the author is saying here. All right, it says, since we want the same information with each dog, we can use objects where we're basically going to set up a blueprint. The example that I've used even in class, even in this class, earlier in the semester, was I talked about blueprints. And I said, imagine wherever you live right now, imagine across the street from you was several hundred acres of land. And a developer came in and bought those several hundred acres of land. And on there said that they were going to put up 100 houses. And each house would be based off of a blueprint. There would be 5 house models. Blueprint 1, Blueprint 2, Blueprint 3, Blueprint 4, and Blueprint 5. And they were literally going to kind of make rows. So you'd have house 1, house 2, house 3, house 4, or house off of Blueprint 1, house off of Blueprint 2, house off of Blueprint 3, house off of Blueprint 4, house off of Blueprint 5. Then the next row, you'd start it up all over again. Each one of those 5 blueprints would be a house class. Each house that you created off of those blueprints would be a house object. All right. Now they mention here, grouping related information together makes code shorter and easy to maintain because, again, you're not doing all of this manipulation, okay? Duplication, even more than that. All righty. It says in the dog sitting example, here's how a programmer could conceivably think about organizing their object-oriented program. Number 1, create a class for all the dogs. Okay, that'd be known as a parent class. Number 2, create subclasses or child classes. Now, all dogs have certain things in common. They do. All dogs do. All right. But after we created a generic type of dog class, we could create child classes where you would have maybe golden retriever class. All right. A beagle class. Sorry about that. All right. Sorry about that. And shame on me for leaving my phone on. All right. So we'd make this dog class. Then we would make, and the dog class would be known as a parent class, or, it's got other names too. Then we'd make class subclasses for each type of dog we had. As it says, we could add unique attributes and behaviors to child classes. So, all dogs have 4 legs, a tail, they all bark, etc. Now you can say, well, what about this dog wasn't an axe? I don't mean that kind of stuff. But if there were things unique, let's say, to a St. Bernard, okay, and we made a St. Bernard child class, we could add that. All right, then we create objects from the child class that represent the dogs within that group. So they show a picture of what they're looking at. So the dog class is a generic template. Then they're going to create 2 of them the way they have it set up here, a herding dog and a tracking dog. All right. So this is what they have. This is the parent. And all they're saying here is that all dogs bark. Okay, fine. So in the parent class, you put things that are in common with all children. Okay, so all of them bark. So they all get bark. Okay, but you'll notice that a herding dog herds where a tracking dog tracks. All right, so we're starting to see the differences between them. And then you can create objects based off of those classes. And that's what they're showing here. Now, the next thing that's here is building blocks of OOP. It says now we're going to take a closer look of classes, objects, methods, and attributes. Well, we've already started to do this. Again, as it says, a class is essentially a user-defined data type. It's, as they mention here, it's a blueprint. All right? So we could say this for dogs. What do we have here? It looks a little confusing, all this junk that's in here. You see class dog, all right? And then you see more stuff down here. All right, well, what we're saying is when you create a dog, you have to pass in a name and a birthday. And then you will set those accordingly. So these two things that are right here, all right, these two things are going to end up being attributes. Then we've got another variable or another attribute here called attendance. All right, you'll notice that it's private, and as it's private, it starts with an underscore. That's just kind of convention. Then we have a series of methods. All right, we've got get age, all right, where we get the age of the dog. And we can find out the exact age by calling another method called calc age. So if we needed to know in days even the age of the dog, we could do this. Bark, all right, this is just very generic. All right, all it's going to say is woof. And then update attendance. So each day that the dog comes to the dog sitting place or whatever it was, we add one. All right, so as it says, remember, the class is a template for modeling a dog, and objects are instantiated from the class. All right, so objects, again, are instances of classes. All right, so we already looked at this. We looked at all this stuff before. We looked at every bit of that. But let's go down a little further. Now we're going to create a new object of the dog class, an individual dog that's going to be named Rufus. So as it says, when the new class dog is called, we're going to create a new object, and it's going to be passed into it a name and a birthday. All right. Now, I don't want to get into this because it can be confusing. All right. As it says, objects have states and behaviors. The state of an object is where it stands at any time. If right now on January 5th, 2024, I am 67 years old, 6 feet tall, 250 pounds, that's my state at the current time. All right. My name won't change. My birth date won't change, etc. Again, you're going to see some examples of this as we go on. All right. So classes, blueprints, objects, instances. All right. Classes contain attributes and behaviors, also known as basically, let's just say attributes and behaviors. Objects contain state, data, and methods. And you say, well, it sounds like it's the same thing. In many ways, it is. So attributes, as it says, represent the information that is stored. When objects are instantiated, individual objects contain data stored in those attributes. The state of an object is defined by the data in the object's fields. Methods, on the other hand, as I mentioned previously, represent behaviors. They perform actions. All right. Now you can look at this and you can say, Okay, I sort of even get it. This is just going to be so hard, I'm never going to get this. If you go into it with that attitude, you probably won't. But I think everybody can understand this after a while. All right. It says methods can modify, update, or delete data. The BARC method doesn't do that. It doesn't update anything. The update attendance does do something. It updates data. It updates the attendance. All right. Methods, as it says, are how programmers promote reusability. Now, I want to give you an example before we go through this. All right. That may make sense and may make very little sense. Let's pretend that I'm not your instructor. I'm a C# programmer. Okay. And I am hired by Enterprise Rent-A-Car. They decide that their whole service for renting out cars needs to be updated. So I update their entire reservation service. I create a reservation class and stuff underneath it, etc. Now, I do this and they're very happy with the job I've done. And in fact, one person who works for Enterprise is married to somebody who works for let's say, the Holiday Inn hotel chain. And they're talking to them about their reservation system and how I've updated it and just how well it works. And the spouse of this person says, you know what? We're thinking of renovating our reservation service here at Holiday Inn. So they contact me and say, hey, would you be able to use your template that you created, make changes to it, of course, and do a reservation system for a hotel? And if I write it in a true object-oriented way, the answer is yes. That's the code reuse. All right. These are the 4 principles of OOP right now. And I'm waiting on something, so I may have to pause this for a bit and come back. But they are encapsulation, abstraction, inheritance, and polymorphism. We're going to cover all of these in the next 4 or 5 chapters. Now, these are one-sentence descriptions. The 4 pillars of object-oriented programming or OOP are, number 1, inheritance. Child classes inherit data and behaviors from the parent class. Now, think about this. Again, I may have given you examples like this before. I don't know. But man with big nose marries woman with big nose. They have baby. Baby has big nose. Probably is going to work that way. So what can baby do about that? Number 1, live with a big nose. Number 2, get a nose job. It's not like they can take their nose off and put on a different one. But that's kind of what you can do with inheritance here, because child classes inherit data and behaviors from the parent. But if they don't like that data, or not really the data, but typically the behaviors, but they can override them and make them do something else, or they can add new things to them. The second one is encapsulation. Containing information in an object, exposing only selected information. Now, there's 2 things I'd like to say about that. Number 1 is I want to give you 2 terms. All right, I'm going to make this nice and big so you can read it. And the first term I'm going to mention right here is interface. And the second term I'm going to mention here is implementation. All right, and I've given this example before. It's an okay example. It's not great. It's not terrible. But as far as these 2 things go, think about this. This is the Windows calculator. All right, when I left off, we were talking about interface and implementation. The interface is just that. It's what you see. So for instance, this is the Windows calculator. All right, if I come in here and I type in 897 and I hit the, well, let's see, if I hit this one, I think that's it, yeah. Okay, what did it do? It gave me the square root. Okay, now how that actually happened, how I got that square root, I don't know. Not to be funny, but I don't care. That's the implementation. So what you do is you basically, when we were talking in here about encapsulation, all right, what is in the object, you only show the person what you need to show them, and you hide the rest, for lack of better words. So this is kind of the public view, and that's kind of the private view, be another way to look at it. All right, we also have abstraction. As it says, only exposing high-level public methods for accessing an object. So the only way you're able to change the state of something typically is going to be through public methods. And polymorphism. Many methods do the same task. We'll get into that one in just a bit. So again, with inheritance, as it says, inheritance supports reusability. If basic attributes and behaviors are defined in a parent class, child classes can be created and they can extend that functionality. All right. Now, there also, when you work with inheritance, it's an is-a or an is-an relationship. For instance, as it says in there, a herding dog is a dog. All right. And whatever the other one was, whatever the other type of dog was, all right, is a dog. Just like if I were to make let's just say I made an account called bank account. I could say a checking account is a bank account. A savings account is a bank account. The what comes after that is the parent. Not only that, it is possible for a child class to have classes underneath it. So a child class can be a child of a parent and a parent of a child. Okay. And they mentioned there the herding dog that they're going to make here. All right, so you got a class of a herding dog, but when you make a herding dog, it'll automatically get everything that was defined in here. As it says, a parent class is also known as a superclass or a base class. The child class can be called a child class, a subclass, a derived class, an extended class. There's a lot of different ones. Again, they go into JavaScript here. I'm not going to do that. And encapsulation, as it says, you want to contain all of the important information inside an object and expose only selected information to the outside world. And I mentioned before I had to stop for a bit, that there was something I wanted to say about that, and it is that in many ways we live our lives in an abstract or an encapsulated world. For instance, this morning I went to breakfast and I got up. My car was in the driveway. I put the car in reverse. I backed out of the driveway and put it back into drive. Now, I don't know literally what happened inside of the car to make that happen. That internal stuff, the implementation of how that was done, was hidden from me. The only thing I needed to know was to go and shift the car into reverse and then shift it again into drive. All right. Encapsulation, it says, requires defining some stuff as private and some as public. And again, pretty much what I talked about before. It's usually going to be that private is normally at least going to be the properties, and public is normally going to be the methods. All right. Now, I've given this example before. Again, maybe not the best example, but let's assume for a second. All right. And I have 3 daughters. Let's assume that 2 of my daughters are at my house. And I want one of them to get me a soda. I don't drink soda, but I want one of them to get me a soda. So I say, Taylor, my oldest daughter, I say, Taylor, would you please get me a soda? And she goes, yeah, sure. So she's going to get me a soda, which is on the other side of the house, but then she sees her sister who owes her a favor. All right, her sister, Chloe. So she said, Chloe, Dad needs a soda. Why don't you go get it? Just bring it back here to me. So Chloe goes and gets the soda, gives it back to Taylor, who gives it to me. Unless they tell me, I don't know that Chloe's the one who got the soda. I don't care. All right. And really, when you do that, when you've got one method that actually calls another method to do something, and that other method that gets called is private, that's typically called a helper method, because that's what it's doing. Again, you'll hear a lot of this terminology as we go through these 4 or 5 chapters. Encapsulation adds security. Attributes and methods can be set to private so they can't be accessed from outside of the class. All right, so we've hit most of the stuff in here that I wanted to hit. The benefits of abstraction, again, adds security, protects against common mistakes. All right. Hides complexity. No one can see what's behind the object's curtain. I kind of like that. All right. And then again, abstraction. We've talked about this before. It's an extension of encapsulation. You want to hide the internal details of the program from the user. All right. So notice again, reduces complexity, improves code readability, facilitates code reuse and organization. It improves data security, and it enhances productivity. All right. Finally, the last one is polymorphism. And, okay, let's imagine that we had this. This is going to be either a real good example or a really bad one, but that's all right. So let's assume that we were creating our own object-oriented hierarchy. So we had here mammals. All right, and then under here we had dog, and we had cat, and we had bird, and I don't know, fish. Trying to think of some mammals. And I'll just leave it at that. In fact, let's move this over. Okay, so this is what we have. All right, and we decide that, what we're going to do is under this mammals thing that's here, we're going to make a method that's going to be called speak. All right. And if we create a dog object that inherits from mammal, it gets speak. But the way that a dog will speak, of course, is different than the way a cat will speak, which of course is different than the way a bird will speak, which of course is different. The fish doesn't really speak, but you get the idea. So each one of these things that's in here will be able to actually speak based on the type of object that it is. All right, and that might not sound like that big a thing, but it really and truly is. All right. So again, the dog speak, woof, or whatever you want to call it. The cat, meow, purr, again, whatever you want to call it. Let's leave the fish out of here and say we've only got these 3. And finally, the bird, tweet or whatever. But each one of these is speaking based on the type of class it is and the type of object you make from that class. All right, that's polymorphism. As it says, it means designing objects so they can share behaviors. All right. Now, a couple terms that you're going to have to get used to hearing in here when we refer to this stuff. And they are, there's two of them. There's one is overloading and one is overriding. All right. Now, we've actually talked about overloading before. You may or may not remember it. You may not look at it this way. But let's suppose, for the overloading example, I did this. I'm going to make this real simple. Int A equals 7. Int B equals 8. Decimal C equals 3.14159. Decimal D equals 67.89. Okay? Now I'm going to write two methods that are going to look virtually identical to one another. All right, so I'm going to type here public int add 2. Let's make this a little smaller so you can see everything that we're working with here. All right. All right, when you look at these two, they're virtually the same except for about three things. Int, decimal, int, decimal, decimal. So these are two methods that have the same name. They're both called add 2. But what's referred to as the signatures for each one are different. And the signatures is basically this part right here. All right. So this one expects 2 integers and returns an integer. This one expects 2 decimals and returns a decimal. That is an overloaded method. All right. Then with the thing I gave you before with this thing right here, let's say that for mammals, I put a speak in here that just says console dot write hello. All right. That's kind of silly because other than humans, in fact, I could have even put a human in there. All right. Yeah, they'd say hello, but I could put anything I wanted to put in here. On the other hand, when I do a dog.speak, it's probably going to say woof or something like that. All right. This will say, let's say meow. And this will say tweet. So if I do, if I make a dog and I call him Spot and I say spot.speak, Spot will say woof. If I've got a cat named Furball, or just furry, and I do a furry.speak, I'm going to get a meow. If I've got a bird that's called, I don't know, Twinkle, and I say twinkle.speak, I'll get a tweet. Well, I defined it up here, but I'm actually right here, I am overriding it right there. Not overloading it, overriding it. I'm taking what normally would be in there and I'm changing it to what I want it to be for that particular type of object. All righty. And like I said, that's pretty much what I wanted to show you from in here. Now, they do talk about compile time, polymorphism, and there's a difference between there's compile time, and I don't know if they show it in this one or not, but there's a run time also. All right, and I'm just going to mention these to you. And that is when things are done. So there's compile time, and compile time is also known as early binding. And there's runtime, which is also known as being late binding. Now, I mean, do you need to know that for what we're doing now? Not exactly, but I just want to explain it. If you create an array in C#, so if I do int bracket numbers equal new int, and let's say I say there's 25, okay? I cannot change the size. In C#, I cannot change the size of that array once I create it. The program, I can add things, I can change the numbers, the values that are in there, but the size won't change. So that's what you do in C#. Those of you last semester, when we had in JavaScript, we would say something like let numbers equal, and we just do that. All right, so that was in JavaScript. That is late binded. What that means is early binded means at compile time, the system needs to know exactly how much space to put aside. But with late binding, it doesn't need to know. So while the program is running, you can change the size of something. All right, so you can do that with JavaScript. You cannot do that with C#. All right. Object-oriented programming requires thinking about the structure of the program and planning out the object-oriented design before you start coding. Sure, I'd agree with that. And I don't know anything about this educative. All right, but it looks like they even have a C# course. And I got kicked off my internet connection again. All right, learn object-oriented programming in C#. It's not going to be free though. Okay, but it's something if you have an interest, you could take a look at. All right, so when I come back, I'm going to jump right into chapter 12 and talk about how to create and use classes. What I plan on doing here, I started by going through and first doing like an example for the first I did an example for the payroll program. Then I went through the PowerPoints, and in the last few chapters, I've changed that up, and I've been going through the PowerPoints first, and that's what I'm going to do in this section right here. So I'll be back with that shortly.